Hello students, welcome to my YouTube channel. Previous class we discussed chapter 1 amines. There we discussed the classification of amines and the IUPAC nomenclature. And in this video we are going to discuss methods of preparation of amines. So in this video we are going to discuss methods of preparation. Okay, so methods of preparation of amines which are very easy, and this methods of preparation which are very useful to convert the reactant to products. Okay, so which will be very helpful in this video. So first one, you can write methods of preparation. Okay, so before going to this video, I will tell you the overall mind map of this chapter. Okay, so overall mind map of this methods of preparation. Okay, so for example, here we have amines. Okay, so this is called mind map. So what are the reagents we are going to use and how to prepare these amines? Okay, the first method, reduction of nitro compounds. Okay, reduction of nitro compounds. And second one, which is called ammonolysis. Third one, using reduction, which we can write reduction of nitriles. Third preparation is the second preparation. And fourth preparation is reduction of amines. And fifth preparation we have Gabriel Phthalimide synthesis. Gabriel Phthalimide synthesis. And we have the last one, the sixth preparation. The sixth preparation is Hoffmann bromamide degradation. Hoffmann bromamide degradation. Okay, so this is the overall outline of the methods of preparation. Okay, so once again we can recall it. So reduction of nitro compounds and ammonolysis. Okay, and ammonolysis is an example of nucleophilic substitution. Nucleophilic substitution. Okay, and here the next one, reduction of nitriles. Reduction of nitriles means the cyanide, right? C triple bond N. And reduction of amides. Okay, what is the amides? R C double bond O NH2. Reduction of amides. And here Gabriel Phthalimide synthesis. This is the specific method which we have to concentrate a lot in this. So here we can prepare only aliphatic primary amines. Only aliphatic primary amines. And sixth method of preparation is Hoffmann bromamide degradation reaction, and which is a very useful method for conversion process. Okay, now the first method will start. So the first method is reduction of nitro compounds, correct? So we have to use, we can take nitrobenzene. Okay, and we have to use HCl. Okay, these are called reducing agents. What is the purpose of reducing agents? This means the reduction, which means that addition of hydrogen or removal of oxygen. Correct. So HCl, or we can use iron HCl, or we can use hydrogen palladium in presence of ethanol. So here ethanol just only solvent. Understood? Now here if you use these reagents, this NO2 will convert to what's the reduction, addition of hydrogen, and we are going to remove the oxygens, right? So here we get NH2. Okay. So here most important conversion, what they will ask you in examination, how will you convert benzene to aniline? Okay. So what is the starting reactant, which is called benzene, and how will you convert from benzene to aniline? Okay. So direct method is not possible. Okay. So direct method is not possible. From this benzene, we have to convert to, we have to add concentrated nitric acid and concentrated sulfuric acid, which is called nitration. Okay. Now we have to convert this benzene to nitrobenzene. From nitrobenzene to aniline, we can use any one of the reagent. Okay. And moreover, here we can use iron HCl, which is the most reactive reagent in this reduction agent. Okay. For example, why? Because of iron reacts with HCl, it forms NeCl2 plus hydrogen. Okay. A small amount of HCl is enough to initiate the reaction. Okay. So this point was mentioned in the NCERT textbook. So here, out of these three reagents, iron HCl is used as a good reducing agent because of small HCl is enough to initiate this reaction. Understood? Yeah. Why? Because of here it generates the hydrogen gas. That hydrogen can be added so that it is acts as a reducing agent. Okay. Fine. And now the second method of preparation is from ammonolysis. Okay. So what is the ammonia? So we can take ammonolysis means. So ammonolysis. So ammonolysis na என்ன அப்படின்னு பாத்தீங்கன்னா, we have to take ammonia. Okay. So starting reagent ammonia. Ammonia reacts with alkyl halide. Okay. RX. So here in RX and ammonia is a lone pair, so which acts as a nucleophile. Okay. So ammonia contains lone pair which acts as nucleophile. So this will undergo nucleophilic substitution. Okay. So now the X group enide, X minus R, it is removed. Okay. So then what's the product? R is attached to the NH3, R NH3 plus and X minus. Okay. So if I now go one H and X can be removed as HX. Then what's the product? R NH2. So we have converted to primary amine. That primary amine, if we have excess of RX, alkyl halides reduction now, we have to go further on this primary amine, further on secondary amine. So other further on tertiary amine. Then further tertiary amine will convert to quaternary ammonium salt. Okay. So this primary amine further reacts with RX. Okay. Again in the nitrogen molecule lone pair NO, which acts as a nucleophile. So nucleophile means this is an example of nucleophilic substitution reaction. Okay. Yeah. So this lone pair attacks this R with X minus the removal. So yeah. So we can write R N H2. Okay. Or we can write the product directly. R one H remove and one halogen remove. R NH single bond R, which means that this is called a secondary amine. Okay. Then we can write one more RX. Okay. So here on lone pair again the nucleophilic substitution takes place. Then it forms R N R R, tertiary amine. This tertiary amine further reacts with RX. Again we have lone pair. Okay. So this reacts with R group. It forms R4N plus and X minus. Okay. So this is called quaternary ammonium salt. Quaternary ammonium salt. I hope it is clear, students. Now let us discuss one example in this. Okay. So இப்போ எக்ஸாம்பிள் பாத்தீங்கன்னா, ஓகே, ஸோ லாட் ஆஃப் கன்வர்ஷன்ஸ் தான் இங்க கேட்பாங்க, சரிங்களா? ஸோ கன்வர்ஷன்ஸ்ல எப்படி கேட்பாங்கன்னா, For example, how will you convert methanamine to N, N dimethyl methanamine? Okay, so how will you convert methanamine to N, dimethyl methanamine? So first, we have to learn the structure. Okay, so then only we can move on to the conversion. So N, dimethylamine nitrogen. Okay, so here we have CH3, and here we have CH3, and here CH3. So it is a tertiary amine. So for converting primary amine to secondary or tertiary, definitely we have to use ammonolysis method. Okay, so அப்ப எப்படி கன்வெர்ட் பண்ணலாம்? CH3NH2. Okay, so அப்ப என்ன பண்ணலாம்? Further we can react with this CH3Cl. Okay, so this lone pair will attack and it undergoes nucleophilic substitution, and here we can write CH3NH3, and further reacts with CH3Cl. Okay, which can be CH3NCH3CH3. Okay, so we convert the primary amine to tertiary amine. Yes, and what are the advantages and disadvantages of this method? Okay, so in the chapter la ammonolysis la enna advantage enna disadvantage appdin pathona. So let us see one ammonia if you take. Okay, so react with CH3Cl. Okay, so if we have excess of CH3Cl, okay, in the CH3Cl excess of emission. Okay, so this CH3Cl only for the reacting, correct? So it will give you primary amine. So primary amine further secondary amine. Secondary amine further tertiary amine, like ordinary ammonium salt, like this it will produce. Okay, so we will have. So that what is the disadvantage? It means that if we have excess of CH3Cl, so will produce mixture of primary, secondary, tertiary, and quaternary ammonium salts. Okay, yeah, and if we have excess of ammonia, அப்போ என்ன ஆகும்? Ammonia ஒரு CH3Cl ஓட react ஆகும். Okay, அப்போ it will stop up to the primary amine. So in examination there are two questions are possible. One question is what are the disadvantages of ammonolysis? Okay, and one more question, if we take excess of ammonia, what it will produce? Or otherwise the question can be asked, so in ammonolysis method if you need only primary amines, okay, so how will you prepare it? Okay, which means that we have to take excess moles of ammonia when compared to the CH3Cl. Yes, so this is the second method of preparation. Okay, yes. Okay, here I will give you one more question. How will you convert? Okay, how will you convert nitrobenzene to N, N dimethyl methanamine? Okay, this question you try it. Okay, I will give you an idea. So how to convert this NO2 into, first we have to convert to NH2, correct? So use thin HCl or iron HCl or hydrogen barbate for reducing. Okay, so you have converted into aniline. From the aniline we have to add two CH reagents, which means that the only possible is ammonolysis method. Okay, yes, thank you. And the third method of preparation is reduction of nitriles. Okay, so reduction of nitriles. So reduction of nitriles here are C-triple-bond-N. Okay, so nitriles are otherwise called as cyanides. So here we can use hydrogen nickel or So hydrogen nickel is selective reducing agent, or you can use sodium amalgam in presence of ethanol. Okay, yeah. So these two reducing agents we can use to convert nitriles to amines. Okay, this can be primary amines. Okay, so how to reduce it? Break the bond, add one hydrogen, add one hydrogen. Now there is a triple bond. If you break the bond means now the triple bond becomes double bond, right? Again break the bond, give one hydrogen and give another hydrogen. Okay, so that will give R CH2 NH2. Okay, so here the most important conversion is, so here I am going to give you how you convert CH3Cl methyl chloride into CH3CH2NH2. Okay, so methyl chloride எப்படி எத்தனை அமீனா கன்வெர்ட் பண்ணனும் அப்படின்ற क्वेश्चनக்கு so it will be very helpful. So RX, okay, so first ஒரு கார்பன் இன்க்ரீஸ் பண்ணனும், then further we have to reduce it. So yeah, so how do you convert this RX alkyl halide to alkyl sinex? We studied haloalkane chapter. We have to add KCN. Okay, so CH3Cl CH3CN convert பண்ணியாச்சு. Okay, now this nitriles to convert to amines, okay, which we can use. Okay, so hydrogen nickel. Okay, and here it is CH3 CH2 NH2. Clear, friends? Yes. Thank you. And now one more, the fourth method of preparation is, okay, fourth method of preparation is from amides. Okay, what is my amides? Which means R C double bond O NH2. Okay, so these amides can be converted to amines, which we can use NiAlH4 in the presence of H2O. Okay, now this NiAlH4, simple, you break the bond, add two hydrogens here and add two hydrogens here. So the product is RCH2 NH2. Okay, so we are using the reducing agent is LiAlH4, lithium aluminum hydride, which is the best reducing agent to reduce what? Carbonyl compounds. Yeah, and here the question is, how will you convert CH3 C double bond O NH2? It's called ethanamide. How will you convert ethanamide to ethanamine? Ethanamine means CH3 CH2 NH2. Okay, so this amide to convert to amine, the same number of carbons. So use LiAlH4 and in presence of H2O, break the bond, add two hydrogens here and add two hydrogens here. Okay, so this is the fourth method of preparation. And fifth method of preparation is, okay, so this is the most important reaction, which is called Gabriel Phthalimide synthesis. Okay, Gabriel Phthalimide synthesis. So before going to this chapter, so I will give you the question, why aryl amines, okay, are aniline cannot be prepared by this method. Okay, so this is the most important question which is asked in the CBSE examination. Why aniline or aryl amines cannot be prepared by this method? Okay, so first let us start. So at the end I will give the answer for it. First let us take phthalimide. So phthalimide means benzene, C double bond O, C double bond O, NH, and we have to add KOH. So when we add KOH, this nitrogen will be more ionic, okay, and it gives the negative charge on the nitrogen, okay. So here we can write in this benzene C double bond O, C double bond O, N, K. This N minus charge, K has plus charge. Now this N minus which acts as a nucleophile. Understood? Yes. So this N minus which acts as a nucleophile, which we can write, for example, I'll write CH3 Br, or I can write CH3Cl, or I can write CH3I. So which halogen, which is very easy to undergo the nucleophile substitution. So we know that Ri is more reactive. So then RBr, then RCl. Okay. Now, so I'm using CH3Br. This nitrogen is acting as a nucleophile. It attacks this CH3, and this Br can be removed. Okay, yes. So then write the product benzene C double bond O, C double bond O, N, CH3. Okay. Add aqueous sodium hydroxide, NaOH. So we have to add 2 moles of NaOH. Then we get the product, break the bond, and give H, give ONA, and break the bond, give H, here ONA. Okay. So in the product varum, abhi badano, benzene C double bond O, ONA, here C double bond O, ONA. Now here we can write RNH2. So we get the primary amine. So here R group is CH3. So here in this question, now we can coming back to this question, why aryl amines or aniline cannot be prepared. Okay. So here we use nucleophilic substitution reaction. Understood? So here we use this alkyl halides will undergo nucleophilic substitution. Okay. And in the place here we want to add, for example, if you want to get the aniline. Okay. So aniline prepare பண்ணனும்னா நம்ம இங்க என்ன யூஸ் பண்ணனும்? CH3NH2 prepare பண்றதுக்கு we use CH3Br. Okay. Then aniline நம்ம என்ன C6H5NH2. இத prepare பண்றதுக்கு we have to use C6H5Br. Okay. So this structure I can write it. Now you can see it, benzene. Okay. 1 bromine is present. Okay. So now this have lone pair of electrons. Okay. Which undergoes resonance. So due to this reason, nucleophilic substitution reaction of haloarenes are very, very less. Okay. So that aromatic primary amines cannot be prepared. Okay. So here in this, it is due to answer for a very important one more question. It is due to aryl halides do not undergo nucleophilic substitution. Okay. Do not undergo nucleophilic substitution with the anion. With the anion formed by phthalimide. Okay, so this is the anion formed by phthalimide. So this is the exact NCERT line. Okay, and for your exam key point, aryl halides. Okay, so do not undergo nucleophilic substitution, which is the very, very important key point as the CBSE examination. Now, next one. The next last question is Hoffmann bromamide degradation reaction. Okay, so what is Hoffmann bromamide degradation? And we have the 6 methods of preparation, which is Hoffmann bromamide degradation reaction. Okay, so what is my Hoffmann bromamide degradation reaction means? We have reacting as amide, R C double bond O NH2. Okay, this amide to convert into amine, R NH2. Okay, so whenever they are giving like RCONH2 amide, you just hide this C double bond O. Whatever we have, you just write it. Okay, so for example, CH3 C double bond O NH2. You just hide this left side, right side. Just combine it and write it. CH3 NH2. Okay, and what we understand in this means here the C double bond O, one carbon is reduced. Okay, so whenever one carbon is reduced, we have to use Hoffmann bromamide degradation reaction. Okay, so now what is a reagent? Okay, so general reaction is R C double bond O NH2 reacts with bromine plus KOH. Okay, and here this RCONH2. Now write the product first, RNH2. Now this K and Br becomes KBr, and potassium and this carbonate, this carbon, it becomes K2CO3. Okay, let us balance this reaction. How many bromine are there? 2 bromines, correct? And you can write 2 KBr. How many total potassium here? Total 4 potassium. So here we can write 4 KOH. So how many oxygens total here? 1 oxygen, and here 4 oxygens. Only 3 oxygens are gone, and the remaining 2 oxygens give 2 moles of H2. Means 2 hydrogens, 2 H2 means 4 hydrogens. Here 4 hydrogens. Okay. So the remaining are only this R and this NH2. Okay. Let us say one more reaction. Benzene C double bond O NH2. Now the question is, how will we convert benzamide, okay, to aniline? Benzamide to aniline. Okay, so the process is very simple. I just told that you just hide this C double bond O and write it. Okay, so what is the procedure? Here we have to add bromine plus KOH. Or you can use bromine plus NaOH. So this is called Hoffmann bromamide degradation reaction. Okay. So in this video we discuss what is the mind map of methods of preparation. We have 6 methods of preparation and how to convert and what are the conversion they will ask you to discuss. Okay. And this next video and fully we are going to discuss conversion reactions based on methods of preparation. And thank you.